So this brings us to another term, which is conjugate acid-base pairs. So you can talk about something being a conjugate base of a particular acid. And so a conjugate base of an acid is a base that's formed after the acid has donated its hydrogen ion. A conjugate acid of a base is the acid that's formed when the base accepts the hydrogen ion. So you can look at those examples here. So we have a pair that we've drawn here with this red line, an acid-base pair, and the other pair is the water and the hydronium ion. All right, let's look at a couple more examples to get the sense of this and figure out what are the acid-base pairs. So one more example. Okay. So now let's look at HCO3 minus in aqueous solution and water going to, again, hydronium ion and CO3 minus 2, also in aqueous solution. So what is HCO3 minus acting as here? As an acid. And so what does that make water? A base. And so the conjugate acid of that base, again, is the hydronium ion concentration. And the conjugate base of the acid is CO3 minus 2 over here. And so in the reverse direction, this base will be accepting a hydrogen ion from the acid, forming the conjugates on the other side. OK. Now you can do an example. Let's have a clicker question. So identify what the acid and the base pairs are here. All right, let's take 10 seconds. Yeah, that's quite good, actually. Yeah, so that's correct, and you can write it in your notes that here we see that there's a little bit of change. Water's doing something different. So instead of the conjugate of water being the hydronium ion, we see it's a hydroxide. So here, the water is acting as an acid, giving off a hydrogen ion to this HCO3 minus. And so now we have a second hydrogen ion over here. We have the H2 species, and that the conjugate of water is OH. So this is acting as a base. It's accepting a hydrogen ion. This is donating it. It's an acid. This is the conjugate acid of that base, and this is the conjugate base of that acid. So in the reverse direction, this is an acid giving off a hydrogen ion to the hydroxide forming water. So one thing that you'll notice about these examples that we've written up is that when you see water in the equation, you don't really know what it's going to be doing until you actually look at what the products are, and then you can figure it out. So water can act as either an acid or a base in these equations. And if we go to the lecture notes, the term is amphoteric, which is a molecule that can act as either an acid or a base, depending on the reaction conditions. So depending on if it's mixed with something that's a stronger acid or a stronger base than it is. And an example, one of the most common examples, is water.